Hi everyone, thank you for coming to our good programming workflow. My name is Mohamed E.
And my name is Apurva M.
My name is George Brodowski. I'm going to be the moderator today. If you have any questions, just put them in the YouTube live stream chat and we'll try to answer all of them at the end during our Q&A session. This is our presentation outline. First, we're going to go a little bit about source control. Then we're going to go over Git. Then we're going to talk about GitHub and code review. Then CI tools, and finally resources.
So to start our presentation, first we're going to discuss what is source control, what does that word mean. So source control is a way to manage information. So in our case, we manage code using source control. Usually source control is stored in the cloud, so it's stored online somewhere in some sort of database. And then the unique thing with source control is every change has a unique marker. We'll go more in depth about that later on when we discuss specific versions that we use. An example, a good way to describe source control is sort of like Google Drive. You have a bunch of changes that are made. Each change has a timestamp. That timestamp could be described as its marker. Hopefully that made sense. And then, so why do we use source control? So we use source control to keep track of changes that happen in our code base. So for example, if we have somebody writing code for a mechanism and they update it, they would make something called a commit. Again, this word we'll go over in a few moments. Each of those changes has a restoration point. So for example, if we mess up and we want to go back, we can always go back to that point where we pushed code. It also is very nice for teams. So robotics teams like us, we use it to collaborate a lot. And we could also use it to branch code. We'll go more about that when we get to Git and GitHub.
All right, so now we're going to be discussing Git. Git is something that 1678 uses for all of our coding. And yeah, so let's jump into it. So Git is a tool that is used to manage source control, just like Mohammed just mentioned. It's a really useful tool for managing your code and everything. It is in fact used by most big companies. You know, you have Google, Microsoft, Facebook, Twitter. All these companies use Git. So not only is it a really effective tool for us to use on our own for source control, but it's something that will definitely help you in the future if you're familiar and learn it now. So some of the most, basic and important commands in Git are adding, committing, and pushing. So adding basically allows Git to track your code. So basically, if you make changes in a file and then you add that file, then it allows Git to, track it. Committing actually gives it a marker. So, you have a set of changes, you've added it to your path, and now you commit those changes, right? So now you've basically assigned a marker to those changes, and if you ever need to refer back to those changes, then you go to that commit message, and that commit is what is used to find those changes. Pushing is basically where you actually update your remote repository using the changes that you have. So now you have all these changes that you've added on your local repository. You've created a commit message, right, to mark those changes, and now you push it. So you actually update the repository upon which your code is stored. And yeah, essentially that's how it works. So a really important part that goes along with, Git adding, committing, and pushing is using branches in Git. So basically, branching is something that you use to split off from other code when you are working on multiple lines of development. Branching is especially important in, team collaborative settings, because if you have, multiple facets of a repository that you want to be working on at once, you want to make sure that everybody can work on essentially their own copy of the code before merging it into your master code base. we do this a lot when we're working on, for example, different subsystems, right? We don't want to write each subsystem one by one, but if you create a separate branch for your subsystem, then you can work on it on essentially your own copy of the repository, and then use that different line of development. The diagram here gives you a bit of an example of how branching works. So you can see here that you have a little feature, right? That if your blue is the master line of development, right? You branch off to work on a little feature, okay? And then you can branch off another time to work on a big feature. Notice that these are two separate lines that you're using to work on your feature before you will integrate it back into your main line of development. And that is essentially what branching is. So our next few commands to go over are git clone, git fetch, and git pull. So cloning is essentially a command you use when you first create a repository or you want to first start working on it. And it essentially copies your repository down onto your local computer where you are writing it and where you are writing code to update your repository, right? And so once you have this repository, then now you can write code, make changes, add those changes, commit, and push. But while cloning is essentially getting that first original copy of your repository, fetching and pulling are what you use to update your local code itself from the repository that you might have on GitHub, right? So fetching itself simply updates your branches, okay? So it basically lets you know what changes that you have on your local code that what changes that you don't have on your local code that you do have where your repository is actually stored. And being able to fetch thus updates your your local code, so you're aware of the changes that there are to be made. Pulling essentially fetches and then merges those changes into your current version of the code on your computer. So it essentially is the difference between fetch and pull thus becomes that while fetching simply retrieves the changes from your master repository, pulling is what is actually used to merge those changes in right away into your local code. So while Git is used on the team to manage code, manage our changes, etc., GitHub is essentially basically where we actually manage to store our code. So GitHub is basically a website that hosts your Git repositories, right? So you have your local code, but then you have your repository online where you're able to manage your versions of the code, all the changes you make, etc. So essentially on GitHub, you're able to view your code, view all these changes when you push, etc. And it's a really helpful tool for being able to view what your repository actually looks like, right? On GitHub, you can view your different branches. You can switch to different versions of the code, and it's basically a really important website to thus become familiar with. GitHub is really nice because it allows you to view all your commits, view all your commit messages, right? But along with viewing a commit message, you have to make sure that your practices in Git are also adequate, right? They're as robust and good as they can be, because that allows your code writing and your repository as a whole to be more clean, efficient, and understandable, right? So a really huge part of this is being able to write a good commit message to begin with. On 1678, we always write a commit message using the imperative tense. So for example, if I added some voltage logic to the elevator, right? Then I would say add voltage logic to elevator, right? Instead of perhaps putting in the past tense and saying that I have added this. Your messages should generally also be short, usually less than 50 or so characters. And you should use you should use your asterisk in the description. Basically a really important part of being able to write commit messages effectively is actually committing atomically, right? when you write a commit message, you want to be able to focus on each separate aspect of the code that you have made changes to. If you add some logic, you want to commit that immediately, because you don't want to incorporate so many changes into a commit that your commit message can't describe the changes you have made, right? So committing atomically meaning that you've committed every time you've made an important change in your code, helps you create these individual unique messages that describe what changes you have made, right? And these obviously work hand in hand, right? Committing atomically allows you to write a good commit message, but at the same time, you want to be committing atomically because then you can go back to very specific changes instead of going back to one version of the code that had incorporated many changes, some that you want and others that you don't. On GitHub, a really important thing that you can do and a really useful thing for our team is creating a pull request, right? So now from your local code, you have added changes, you have committed them, and you have pushed them, right? But when you want to actually, take your branch, right, take your line of development and finish it, right, so you can merge it with your master code, it's a really good practice to create a pull request to do so. A pull request is essentially a request that says, okay, I want to merge from my line of development into the master code. And it essentially creates this review that you can use, right? So when you create a PR for every feature, it's really important because it helps you avoid having too many parts of the code to review at once. But it's really nice because you can make sure that all the code that you are merging is exactly what you want to merge, right? You're not accidentally updating your code base with things that you don't want that you can't easily get rid of. So being able to have a pull request for every feature and then have substantial reviews on that code is a really good practice to have. And yeah. So pull requests and code review obviously go hand in hand, right? But what is code review? Code review is essentially having another human, right, another programmer reading your code, okay? And code review encapsulates providing feedback on things that you could change, and very importantly, asking a lot of questions. In the pictures on the right, you can see a lot of questions that previous members of 1678 software robot team have discussed, right? It could be as simple as the top picture where we have somebody asking, what do these variables and values mean, right? And a second picture that actually just describes your inputs, outputs, and the specifics of a certain function, perhaps, right? But being able to ask these questions allows everybody to look more closely at the code to ensure that the logic is correct, that the values for different variables are correct, that you aren't essentially messing something up that you weren't able to track or weren't able to catch before it became part of your master code base, right? At the same time, of course, you want to provide feedback, right? This feedback could be about the actual logic of perhaps a subsystem mechanism, right? If I think that logic for a current spike is slightly incorrect and it won't do exactly what we need it to, then I could provide feedback on that. But it might also just be to add more documentation to the code or clean it up a little bit so it's easier to read for others, right? And all this feedback is a really important part of code review because it allows your code to be better, and you're allowed to make those changes on your separate feature before it's actually merged into your master code, which is why, again, those pull requests are so important because you're able to check your features before, it's a bit more difficult to make those changes. Yeah, and so, discussing more about the importance of code review, we've discussed now that it really helps you catch, your logic mistakes, right? So again, another example is making sure that you're working in degrees and not radians, right? That you have the correct units for some variable. But at the same time, from a more holistic point of view, code review is really important because it allows for better understanding and practices on your subteam as a whole, right? by having these pull requests, by having these code reviews, right, you're able to update all your members on the code, right? On 1678, we really like making sure that we can get as many reviews from programmers as possible, right? And so this is a really important process because everybody learns, right? And everybody is aware of what changes are being made to our code repository. And everybody understands, what different lines of development there are currently in progress. At the same time, you can learn by both asking questions and explaining code in, code review, right? If you have questions about logic and somebody else explains that to you, then you learn what's going on. If it's a specific question about how a mechanism is to function, right? That's something else that you can learn from doing code reviews. So by having these comments and questions always flowing through when you are working on features is a really important part. And I think especially in this time, right, where you can't simply just go to a fellow programmer in person and ask them, right? It becomes even more essential that you're able to do such review because you want to make sure that communication is properly functioning and that everybody is aware of what is going on the subteam.
So code review on 1678. So our robotics team is actually split up into two subteams. We have the software scouting subteam and the software robot subteam. The software scouting subteam creates an app that we use every year to scout data. So we actually have two different ways of reviewing code on both subteams. So we'll start with software scouting. Software scouting requires a peer review. So basically they have different app groups because they have different, they have a back end, a front end, they have different database team. Basically, so the peer review is there to explain the code. When you're reviewing this code with the peer might not necessarily know the same language, but it helps you basically explain your logic, explain the code in a way that anyone can understand it, even if they don't program in the same language. A buddy review is a review from a developer in your app group. So if you're working on the front end, a second front end developer would review your code for a software scouting repo. On software robot, it's kind of different. So on software robot, we require 2 reviews at least. Those 2 must have 2 veterans at least. So like you want 2 veterans to review the PR before it gets merged. Every pull request should have a test. So test-driven development is something we use on our subteam. And the subteam lead, so the software robot subteam lead, has to approve the merge before it gets merged. The lead doesn't necessarily have to merge it themselves, but just as long as it's approved, the lead knows what's getting managed in the code base. And there's always that one point of reference that knows exactly what happened in the code base. So continuous integration tools. So continuous integration is a pretty big part of why our code base works, why source control is really nice. So what is CI? What is continuous integration? So basically it's an automated test that builds your code. And if you have any tests, it also runs them for you. In addition, there are certain tests you can run that can test for styling. For example, in C++, there is a test you can run to make sure that you follow the Google style guide. In addition to all of this is all hosted on a server. So your code gets pushed to GitHub. It gets sent to that server. It gets run, built, tested, and then the server returns whether all your tests failed or passed or failed. If they passed, there'll be a little green check mark in GitHub. That's how our GitHub works. I'll go over more in a second. So why we use continuous integration. So as I mentioned before, the tests make sure that everything is uniform with style tests. In addition, it makes sure that all the tests works, all the code works. Any test you have works. It's just an extra layer of security that we have to make sure that anything that gets merged into our code base works. You don't want to have a code base that everyone uses that doesn't compile. That causes a headache. It's a pain to fix, and especially if it's noticed very late, it's just painful to fix. So the whole continuous integration cycle. So first, the user writes code, they build it on their local computer, they send it to Git. From there, it gets built onto the continuous integration server. It gets built, tested, and then it returns whether it failed or passed. And then if it failed, it might run it again if you have it configured to that. If not, it'll return a fail. On our subteam, if the CI fails, the code cannot get merged unless the subteam lead does it with a force merge. So on such circuits, we use something called BuildKite. So we use BuildKite because it has robust webhook support. It also lets us test style. So we have JUnit tests, and if all the tests pass, for example, a drivetrain test, if that passes, it lets us know, and it lets everyone know that the code is good to merge, and the code compiles, which is very important. So code practice. So code practice is pretty important when you're writing code. So we'll start with naming conventions. On Citrus circuits, we have a bunch of naming conventions that we follow to make sure that everything looks consistent. It keeps continuity. It keeps the code uniform. It also helps with collaboration. So for example, if 10 people are writing code and they're all following the same style guide is just another way for a naming convention. All the code looks the exact same regardless. So if you have a pull request, you can say, oh yeah, hey, like your naming doesn't follow the style guide, please fix it. Or you wrote your if statement in a way that doesn't follow our style guide. Your braces are underneath the line when it should be next to the line. So stuff like that. So part of reviewing code is following these code practices.
So on 1678, the bring up process is really important to be done as a multi-step process. And frankly, bring up should always be done as a multi-step process because, for one, everybody's worked really hard on this mechanism, right? We want to make sure that we're able to use it correctly and nothing goes very wrong in our first bit of testing, right? And at the same time, we also want to make sure that everybody around the robot is completely safe, right? So one of the most important parts of bring up is making sure that you begin your testing of a mechanism with low voltage. Okay. If you don't have low voltage to begin with for a mechanism, right, and it does something that you don't want it to do, right, you could obviously cause severe damage to the mechanism or anybody that might be around the robot, right? If you have, for example, in 2019, a really important part about the bring up of our arm was that we had to make sure that it was low voltage. So if we were testing logic where our arm was to pass through the frame of our robot, we didn't accidentally hit the limelight that was at the top of our frame. And starting off really low voltage to make sure that, even if there is an error with our code logic or anything, being able to make sure that you're starting low voltage ensures that even if there's a mistake, you can catch it quickly and everything is still under control. Something that goes hand in hand with working with voltage and etc. is making sure that you move from simple logic to complicated logic when you are doing your mechanism bring up, right? You want to first be able to make sure that you're testing the smaller parts of the mechanism, right? Just the opening and closing of a claw, for example, before you jump right into actually passing an arm through the entire robot, right? And being able to work on this step-by-step process also ensures that you can single out, any issues that you may find, right? By working on each individual part of a mechanism, working step-by-step through the bring up of something ensures that if there is a problem, you can be aware of it right away and you can fix it before you move on, because you don't want these issues to compound, right? You don't want there to be a problem with the proxy, for example, in your intake and something else that you can't manage to find because you didn't go step by step through the entire process, right? And a really important thing to think about throughout all of this, right, is again just you want to make sure that everybody around you is safe, right? If you're working on an elevator, you want to make sure it is low voltage and you are moving from the simple to more complicated logic step by step, right? And building up, your testing to make sure that nobody is hurt around you. And doing this is really important for the overall success of a mechanism too, because you want to be able to ensure that it's doing exactly what you want, and you can again single out these problems when you need to. So discussing mechanisms, right, something really important to think about when you are writing code is how you can automate tasks that you are going to need to complete. For example, when right after we have our kickoff and whatever, right, 1678 programmers start working immediately on writing our subsystems, right, or at least formulating the idea of what each subsystem on our robot is supposed to be doing. And something really important to think about throughout the entire season is making sure that you can automate tasks for each separate mechanism, so you aren't creating a more strenuous load for your operator to be able to control. The GIF on the left here is actually our 2019 climb for our 1678 robot, and I think this is a really good example of how you can automate tasks, right? In 2019, we didn't want the operator to have to balance and figure out exactly which height they should be at on their own, because one, that would take a lot of time in an actual match, right? And two, we want to make sure that the task was actually completed. If in a rush the operator was not able to bring it to exactly the right height, then we could have our robot tip over, we could have it go too far and have part of the mechanism break. And these are all things, right, that you don't want to have at risk, right? So by providing a safe contingency, by automating that task to begin with, it becomes really important, and it becomes really useful for the operator, because with the press of one or two buttons, you can do each of these tasks, right? You can press one button on a controller and that will move it to the height you need it to. And I would like to stress again that task efficiency is far better when you have these automated tasks, because you are able to test exactly what your mechanism is to do, and exactly what with at what rate, like what's the rate at which your mechanism is going to be completing a task. And you can, if you have that task automated, then you can actually hone down on that time and see whether you can do something faster and faster. You can up the voltage or do something else to see if that task could be completed faster. Along with this, again, testing is key for consistency of the mechanism and the task that you are trying to do overall, right? Again, with the 2019 climb, right? Because we were able to automate it and test it a bunch, we were able to make sure that it worked consistently every time. Consistency is really important for your other mechanisms as well, right? In 2019, the same robot, we wanted to make sure that our vision tracking to actually place a hatch panel on our on the rocket for that year work consistently every time, right? So being able to automate our vision tracking, so our operator, our driver could just press a button and the robot could move the way it needed to get that hatch panel on, allows for much more consistent hatch panel placement, right? Than having the operator every single time use their own ability to try to place that hatch panel. And you have to really think about these trade-offs when you actually are doing your code writing, right? For example, in 2019, if you didn't have that consistent hatch panel placement, then occasionally you could lose lots of points, right? Because if you placed a hatch panel a bit warily on that on the Velcro, and then you added a cargo, and once you added your cargo, both your hatch panel and then the cargo both fell out the rocket ship, then that would be really devastating, right? Because you would have to do those two tasks again, and that is basically the loss of an entire cycle right there in the match. So having this task automation allows for consistency and efficiency of completing those objectives that makes basically your robot a lot more robust and a lot more effective at competition within a match as well. And the last thing to kind of touch upon is that while it's easier for the operator in most cases to automate tasks, at times automating a task really removes something that would be impossible otherwise, right? If you automate basically your your logic, again, I'll use the 2019 robot for when the arm can pass through our robot to make sure that the arm doesn't hit our limelight or anything else, right? By being able to work that logic out and automate our robot passing through our arm passing through the robot, we don't have to have the operator stress about that at all, right? So if it would be impossible for the operator to really make sure that the arm is in correct placement at the correct time in a match, by automating that task, you can make sure that your arm really will be in the position you want it to be. So it's important to think about how automating tasks not only makes a match for a robot a lot easier, but at times it brings in possibilities to do things within a match that you wouldn't be able to do otherwise. And yeah. So something really important that comes through with all of this, right? With your bring up process, with your task automation, and writing code in general is how to actually troubleshoot your code, right? Everybody's going to have a lot of mistakes that they catch in their code, a lot of different issues to handle, and there are a lot of different more simple devices even that you could use to do such troubleshooting for a mechanism or on your robot in general. A really important thing to do to troubleshoot is basically trace your code overall. And what I mean by tracing your code is being able to understand what variables are being used where, what functions are being called at what point in time, and what the value, for example, of the proxy on a mechanism at a certain point in time is. So a really important and simple tool to use in tracing your code is using print statements, right? If you don't know what the value of, for example, your arm voltage is at a given time, then you should just print it out, right? And you should see whether it is what you want it to be or if it isn't, right? You could print out the status of a proxy to see if it's being triggered or not, right? And having these print statements all throughout your code when you're doing testing, or adding a print statement in to see what the status of a mechanism is at a certain point in time in your bring up, is really helpful for being able to do this troubleshooting, right? But another important thing to really be sure of and think about actually goes back to the beginning of this presentation when we were talking about Git and GitHub, right? A really cool thing about writing your commit messages and pushing and doing atomic committing, right, as we discussed, and essentially the importance of those things is that it allows you to revert back to a working copy if you ever need it, right? If I find a mistake in the logic that I induced while doing bring up, right, and I don't remember exactly what logic I was using before on a mechanism, then I don't need to worry about it because I know that I have that logic in a commit message, and I can just revert back to that hash to go back to that working copy, right? And this is really important because not only does it allow you to test and make sure that your code isn't being lost, but at the same time, it allows you to have robust testing where you're not going to mess something up within a repository that you won't be able to fix. And so that gives you a lot of more leeway in being able to do the work you want to do with your mechanism, right? And because of that, it's really important again to have these commit messages because if I was working on some logic for the climber and the climber height, and I don't remember what height I was using for even just a variable value, right, in my current code, then being able to know the commit in which I made that exact change for that variable becomes really important because I don't want to have to shift through all this code to find what value for that height actually worked. So having these effective commit messages becomes even more crucial to all of the other processes you do with your robot, troubleshooting, bring up, automating tasks, etc. And this is a bit more of an unfortunate point to make, but if you really are facing problems with your mechanism that you can't fix, that you can't find an answer to, then at a certain point in time, it might become more effective to just start over, right? If you start over, you can have a fresh slate to work off of. You can, I mean, you should be able to remember what should go into your mechanism anyways, right? Your planning, your structure should be similar. But if you start over, then you might be able to catch a logic error or rewrite logic in a way that makes it work the second time around instead of the first. And yeah, obviously though, before you start over, you should try these other tactics to check your variables, check your functions, etc. Use print messages and trace your code to do troubleshooting however possible, because you will definitely be able to have help in finding a problem that way. And I think the last important one of the last important points I'd like to make about troubleshooting overall is the use of something like a shuffleboard on your driver station, right? So during a match, and when you're testing the robot in general, right, if you're operating it using your driver station, then having something like a shuffleboard in which you can view data is really important. So 1678 uses, as I've been saying, shuffleboard. It's essentially this FRC dashboard that you can use to output a bunch of values from your robot to a page and track a lot of different things. So the shuffleboard is really important because it acts as a really good debugging tool, right? If you're not sure about whether your motor is providing adequate power, then as you can kind of see here, you can plot those values, right? You can see if there's current spikes, for example, going on, etc., by outputting those values onto a dashboard from which you can view values, right? You can put in simple boxes for seeing when a proxy triggers and when it doesn't, and that way you don't have to even look at a print message every time in your code because you are simply outputting it to that dashboard to begin with. And this is, a really robust process because it helps with troubleshooting, but it also makes sure that the status of your robot at any given time, right? So it's a really good idea to get down with your sub team, right? Sit down and understand what are the different values, what are the different things that you would like each mechanism to track, and you can simply then output those values to a dashboard to view that data. It also helps a lot with electrical troubleshooting and these other problems, being able to identify whether a technical issue on the robot comes from the software side or an electrical side, right, or a mechanical side. So being able to use a dashboard to make those distinctions by outputting different values, different variables, different mechanism statuses, right, that becomes really important. And I think that a dashboard is just a really good tool to be able to use throughout your bring up and your task automation.
So something that's pretty important when you have you're trying to have a good workflow basically is you want to have documentation in your code. So documentation in your code has a bunch of benefits. So for example, comments in your code, that's a form of documentation. That adds clarification. It also helps guide people who might have not read your code before. Every year we do a code, push our code out to a public repo where people can view our code. And we try to document as much of our code as possible. So we add comments in. We might have GitHub wiki pages. In addition to this, it also creates a sustainable system. So this basically means that we are able to people who might have not been on the team before can read through the code and then read through the comments. The comments are explain the code well and can clarify the code well. Even if they don't understand necessarily every single line in that code, they can understand what the purpose of it is. In addition to code comments being a clarification, they can also add guidance. In Java, you can add comments on top of code when you use it, so it shows up in your IDE. So that's really nice for people who might have not used a code base before when they're using different methods or functions. So control in robotics. So control is something that's really important when you're writing code. When you control a robot, you never want to base it off just voltage. You want to add some sort of control in. So on such a circuits, we use something called PID. That stands for proportional, integral, and derivative. That controls the voltage of the robot. So proportional basically gives, so there's an error, right? There's where you are and a goal. Then there's an error in between. So how far you are away from the goal. Based off that error, you're going to give it a proportional amount of voltage to control it. Then based off your derivative of that, so your change, you want to add a factor on top of that, add a gain. So there's a P gain, an I gain, and a D. It's a P gain, an I gain, and a D gain. Each of those gains contribute to controlling the voltage of that mechanism. Using PID, you have an efficient and reliable system that gets to a goal in the fastest amount of time. So on the right, there's a GIF. Basically, it follows this weird pathing, and then it overshoots, and then you undershoot a little bit, and then you add some I, which makes it overshoot even more, but you get steadier to the goal. And when you add your D, you get this nice consistent line where it gets to the goal really, really fast and stays at that goal without having any jittering. Another thing about PID, especially in FRC, is that the CTRE and rev controllers have them built in with methods that you can use in your code. So if you don't want to have your own implementation, you could just use the ones that are built into CTRE and rev. So team management. So on such circuits, we try to have our team management be as clear and transparent as possible. We use a platform called Slack to communicate with everyone, and we use Slack to delegate tasks. It also keeps documentation of what we've done, and it's also efficient. On the right is a screenshot of something that happened this year in 2020. Before going to LA North, we had a lot to do. That weekend in particular, we got a lot done. And then the comments basically say like, oh yeah, like what happened, any issues we might have had, how we fixed it, and then stuff we still need to do. It also delegates tasks at the bottom. It's not shown in the screenshot, but yeah, so managing your team is really important when you have a good workflow. You don't want two people working at the same thing at once unless it's assigned to both of them at the same time. It also keeps everyone in the loop. So when you send out a message like the one on the right, everyone reads over it. Everyone understands what happened. They also can learn from it. Like, oh yeah, we changed the code because this didn't work, and you explain why. For example, the climber testing. At the very bottom, it says we automated the buddy and solo climb, and then we found the high presets. That lets everyone on the team know that now when you're climbing, that's automated. So every programmer reads through these status updates, and people from outside the software subteam can also read them and understand like what's going on in the software robot subteam. So here are some resources that you can use that we found pretty helpful. The first one, try.github.io, just goes over a bunch of Git commands. Our code release can be found at github.com/frc1678. If you want to learn how to branch, a really nice website for that is learngitbranching.js.org. That's basically an interactive Git branching That's an interactive practice for using Git. And then if you want to learn more about control, one of our alumni, Wesley, has a blog post, and the URL at the bottom. As always, if you're watching this not live, you can contact us at software@citruscircus.org, or you can email my personal address at mohamedeprogramming@gmail.com. Thank you all for joining, and we'll open the floor for questions.
So looks like we only have one question right now. The question is, what's the difference between push and commit?
So the
So
important difference between pushing and committing is that you can make, okay, for one, you can make multiple commit messages within one push. But essentially what committing does is add a marker to a set of changes that you make, right? So if you change one thing in your system, right, in your subsystem, in your code, then you can add a commit for those changes, right? And that marker basically labels those changes and says, okay, at this point in time in the code, these are the changes that we have made. Okay. But usually you don't need to push for every single commit, even though it isn't a bad idea to do so, right? You want to update your repository. You want to update your repository with all the changes you make. But essentially, the difference between pushing and committing is that committing essentially adds that label to those set of changes, whereas pushing sets, pushing essentially, takes those commits, takes those changes, and updates GitHub with them. And that's, the big difference. You can have a lot of changes that you make in one day, and you committed each of those changes, and then at the end of the day, you do one bigger push to update the GitHub repository. But essentially, pushing updates your GitHub repository, and committing adds a marker to all the changes for the push that you make.
So think of committing.
Someone just asked if.
I was gonna add on last point.
Sorry, you can
think of
finish,
committing.
Mohammed.
Okay. Think of committing as giving your set of changes just a marker, and then when you push, you send it to the cloud. You send it to just a Git cloud, basically. So it's off your local computer and in the cloud now. That's just the main distinction. Is one gives it a marker and one pushes it to the cloud. And when you push any commit, if you have like 10 commits that haven't been pushed, all of those get pushed at the same time, unless you use specific extra commands.
So somebody asked if we could go back to the resources section.
Yeah, for sure.
Might be a good idea to maybe write down these links or take a screenshot if anyone would like to save these for later. And we also have another question. How essential is Git to programming in general, not just for first?
Can you say that one more time, George?
How essential is Git to programming in general, not just for first?
So a lot of big companies use Git. So for example, Google, I know use Git. I think Apple might use Git. But if you have a large team that you have to manage, or if you're just working like a duo, as two people are working on a code base, Git helps you manage the code base. It's very rare to find a successful company that doesn't use source control. It doesn't necessarily have to be Git, but most successful companies have some sort of source control due to its importance and all the benefits you get from it. You get a lot of transparency with it, so anyone working on code is able to see all the code. It also, I know some people might use Dropbox or Google Drive to manage the code, but the thing with that is you don't have all these tools that Git gives you, or you don't get pull requests either. So all the tools that Git gives you, or source control in general gives you, are very useful, not just in first. So for example, let's say you're working on an app, and you're creating a new button, or you're changing a button, but someone else is working on a banner. Those two people can work at the same time without having to worry about trying to figure out how to have those two code bases merge into one, because Git helps you manage that by merging automatically. And if it doesn't merge automatically, it tells you need to fix these changes or go over it manually. And it's very rare for anyone that knows how to use Git properly to mess up. So you'll always have a consistent code base that works, that everyone can update from.
A perspective I'd like to add is that Git and GitHub can be really important even out of the realm of engineering and computer science and coding for some company, right? 1678 is actually centered out of Davis, California, so we have UC Davis right next to us, and a lot of research groups at UC Davis use GitHub and Git as a part of their research code bases because especially when you're working in, for example, a field like computational biology or bioinformatics, you have to write code, and even though it might be more simple or it might be simply related to data science, right? If you have multiple members of a research lab that are working on a lab's code base, right, then Git and GitHub can be really essential because some of those members might need to use features in code that others have created, right? So being able to have Git and tracking those changes is, I would say, just as important in a field like research because, if you manage to find, one way to do data manipulation, right? Or you find one, pathway to, producing some amount of statistics or data on a subject that you are doing research for, then being able to have those changes tracked at all times within your code so you know how you can go back to those results, you can repeat those results, how you can automate your code to do those computations is really essential. So, using commits and pushing frequently, having these atomic commits and, using GitHub to track your code becomes really essential in that sort of setting as well.
Any more questions?
No, that's all for now.
Awesome. Thank you all for coming to our fall workshop. We hope you enjoyed it. Bye.
And again, we have our, you can reach out to software@citruscircuits.org or, Mohamed's personal email if you think of any questions after this or you would like any, help or support. These are really, these are very different times right now. And, we're all figuring it out together. But if you have any questions at all, then please feel free to reach out. We will be able to answer those questions as fast as possible.